Is there life beyond Earth? For centuries, that question has ignited our imaginations, driving explorers, scientists, and dreamers alike. From science fiction to groundbreaking research, the search for extraterrestrial life remains one of humanity's greatest mysteries. But what if the story of life on Mars is more complex and more intriguing than we ever imagined? Recent discoveries have brought us tantalizingly close to uncovering the truth. Did life ever exist on the Red Planet? And if so, why does the mystery of its decline remain unsolved? Join us as we delve into the captivating enigma of Mars' hidden past and explore the unanswered questions that continue to challenge our understanding of life beyond Earth. This is The Unsolved Decline of Life on Mars. Let's uncover the secrets of the Red Planet together, the organic clues hidden in Martian rocks. Contrary to the popular image of intelligent extraterrestrials, the first step in understanding life on Mars is to look for the building blocks of life itself, organic molecules. NASA's Curiosity rover has made remarkable progress in this area, uncovering the biggest organic molecules ever detected on Mars. These molecules were found in ancient Martian rocks dating back approximately 3.7 billion years. Organic molecules are carbon-based compounds often associated with life, but their presence alone doesn't confirm life existed on Mars. Instead, they are the raw ingredients, leftovers from processes that involve fatty acids, amino acids, and other complex compounds that help build cellular structures. Their survival over billions of years suggests that Mars once had conditions capable of preserving these organic signatures. The search for ancient Mars habitats. Curiosity's mission has taken it to Gale Crater, a massive impact site believed to have been a lake billions of years ago. Scientists hypothesize that Gale Crater's ancient waters provided a potentially habitable environment, making it a prime location for searching for signs of past life. In 2016, Curiosity drilled into a rock called Cumberland, collecting powdered rock samples. Using a sophisticated onboard oven that heats samples to about 1,500 degrees Fahrenheit, scientists examined the gases released during heating. They discovered chains of carbon atoms up to 12 units long, similar to hydrocarbon chains found in crude oil and living organisms on Earth. While these molecules can form through non-biological reactions, such as interactions with water, minerals, and heat, their presence hints at the possibility of past microbial life, or at least a planet that once supported it. Most intriguingly, these organic molecules are surprisingly resilient. On Earth, sunlight, oxygen, and water break down such fragile molecules over time. That they remain preserved on Mars after billions of years suggests that the planet's environment was once conducive to the preservation of organic compounds. This increases the likelihood that traces of ancient life could still be hiding within Martian rocks, waiting to be uncovered by future missions. Building a case with more organic evidence. Curiosity isn't the only rover to find organics on Mars. It has also detected chlorinated organics, sulfur compounds, and nitrates, ingredients that, on Earth, are associated with biological activity. These findings make the case stronger that Mars once possessed the necessary ingredients for life, even if it never actually developed into a thriving biosphere. Perseverance and the search for microbial life. While Curiosity has laid the groundwork, NASA's newer rover, Perseverance, is on an even more ambitious quest. Launched in July 2020, Perseverance landed in Jezero Crater, a site believed to have hosted a lake and river delta around 3.5 billion years ago. Its goal, to find direct evidence of past microbial life and collect samples for future return to Earth. Perseverance is equipped with cutting-edge technology, 7 scientific instruments, 19 cameras, and even microphones to capture sounds from Mars. It also carried a mini helicopter named Ingenuity, which made history by performing the first powered flight on another planet in April 2021. Although Ingenuity has now been retired due to damage, its flights opened the door for aerial exploration of extraterrestrial terrains. Since landing, Perseverance has actively explored Mars geology, hunting for signs of past water activity and habitable environments. It has discovered volcanic rocks that interacted with water, signs of an ancient lake at Wildcat Ridge, and sediments that indicate a changing climate over millions of years. These clues are essential for understanding whether life could have taken hold there. The evidence of water and habitability. One of Perseverance's key findings is the presence of volcanic rocks that show signs of water interaction, an essential ingredient for life. The rover also found sediments deposited in calm water environments, as well as evidence of massive floods that reshaped the Martian landscape. These findings suggest that Mars experienced dynamic climate changes, alternating between wet and dry periods. Moreover, Perseverance's experiments have demonstrated that it's possible to produce oxygen from the Martian atmosphere, a crucial step toward future human habitation. Its onboard device, MOXIE, has successfully converted CO2 into oxygen, hinting at the possibility of supporting future astronauts on Mars. The challenges of Martian life. Despite these exciting discoveries, living on Mars remains a daunting challenge. The planet's environment is incredibly hostile. Its atmosphere is 95% carbon dioxide, with surface pressure less than 1% of Earth's. If humans step outside without protection, they'd face instant vaporization of bodily fluids. The thin atmosphere offers almost no protection from lethal cosmic radiation, which is 40 to 50 times higher than on Earth. The planet's weather is extreme, with dust storms that can last for days and winds reaching up to 250 miles per hour. Temperatures average around -62 degrees Celsius, plummeting to -140 degrees Celsius during winter. The soil contains toxic chemicals, making agriculture difficult or impossible without advanced technology. Additionally, Mars's gravity, about a third of Earth's, raises concerns about long-term health effects like muscle atrophy and bone loss. Terraforming Mars. Is it possible? Given these challenges, some scientists and visionaries have proposed transforming Mars into a more Earth-like environment, an endeavour called terraforming. The idea is to modify the planet's atmosphere, temperature, and surface conditions to support human life naturally. One radical plan involves bombing the polar ice caps with nuclear devices to release trapped greenhouse gases, creating a runaway greenhouse effect that warms the planet. This approach, however, is fraught with risks, including triggering a planetary nuclear winter that could make Mars even colder. Another idea involves installing giant mirrors in orbit to reflect sunlight onto the southern ice caps, melting them gradually. While innovative, such projects are currently beyond our technological capabilities, requiring massive engineering feats, like constructing a mirror larger than Denmark in space, creating a breathable atmosphere. Warming Mars alone isn't enough. The planet also needs an oxygen-rich atmosphere. Currently, NASA's Perseverance has demonstrated the ability to convert CO2 into oxygen on site, but scaling this process for the entire planet is a colossal task. One plausible solution is transporting nitrogen-rich materials, such as asteroids or icy moons like Titan, loaded with nitrogen to Mars, gradually building a breathable atmosphere. The timeframe and ethical dilemmas. Terraforming Mars, even with futuristic technology, is a process that could take centuries or even millennia. Estimates suggest it might require on the order of 100,000 years, far beyond a human lifetime. That raises ethical questions. Should humans modify another planet so drastically? Do we have the right to alter alien worlds? And what responsibilities do we bear for potential indigenous microbial life, should it exist? Some experts argue that building artificial habitats, underground or on the surface, might be a more feasible and immediate solution. Elon Musk's ambitious plan to establish a city of 1 million people on Mars by 2050 is a testament to the human desire for exploration and expansion, albeit with enormous costs estimated at around $10 trillion. The future of humanity on Mars. Despite the immense technical, environmental, and ethical hurdles, colonizing Mars remains a tantalizing goal. It embodies humanity's innate drive to explore, adapt, and survive beyond our home planet. Whether through terraforming, building self-sustaining habitats, or simply establishing outposts, our future might very well involve setting foot on the red planet. The search for life on Mars is ongoing, revealing tantalizing clues that the planet once hosted conditions suitable for life. While we are still far from confirming whether Mars ever harbored microbial organisms, each discovery brings us closer to answering one of science's most profound questions: are we alone? As technology advances and our understanding deepens, the possibility of human migration to Mars becomes less science fiction and more tangible reality. But with that possibility comes responsibility: to explore ethically, to prepare thoroughly, and to consider whether humanity is ready for its next great adventure among the stars.